Hi there, we're doing Think Out Loud for Biweekly Contest 32. We're gonna try the last problem, which is find longest awesome substring. People have done all of the questions in 8 minutes, but I'm not sure if we're gonna be able to do this one. I am not that good with the hard questions, but let's see how it goes. Let's think out loud and let's try to figure out if it works. So, given a string S, an awesome substring is a non-empty substring of S, such that we can make any number of swaps in order to make a palindrome. Return the length of the maximum length awesome substring of S. Okay. So 24241 is the longest awesome substring. We can form the palindrome 24142 with some scraps. Okay. 213123 is the longest because we can get that. Okay. I think we might be able to do this. So let's see. If we want to make a palindrome and we're only given the digits, then all we need to ensure is that all the digits have been occurring exactly twice, or in multiples if 2 also works. Okay. Yeah, not exactly twice. They should exist in pairs, and there can be one. Okay. We also don't need a single one. So if we have three ones, even then it works, right? So the counts, all of the counts should be even, and one of them should have an odd count. If that satisfies, that holds true, then we're in luck. Then we got a palindrome. But if there's no odd even, then we got a palindrome, right? Because we can have just four ones or four twos or anything like that. Yeah, yeah, we can do that. Alright, so all of them should be even, and at max one count can be odd. Okay, yeah, but how would we check for the longest awesome substring? Checking for all substrings might not really be feasible, right? Because starting at the first one, we have n substrings. Starting at the second, we have some more. Third, we have some more, and so on. So this might require dynamic programming. I feel if we because we might just save the counts, right? If we start at the first one and go till the end, then starting at the second and going till the end is just a subset of the first problem. So we might already have the counts. Hmm. But not sure. So there's also a thing called sliding window, but I am not really sure how can we use that because we start from the first character, we increase it, we can go till the end, and maybe at the end it's becoming a palindrome, right? Because yeah, because we can. No, that might not be true. We might not need to go till the end for it to become a palindrome if it's like too long string. What can we do? Um, I am drawing a little clueless here, so if I was in an interview, I would have just expressed all this and then asked the interviewer for a hint. But given that we are in a contest, we need to figure out what to do next. We don't have any hint. Okay, Right, so if we think about brute force, they are 10 to the power 5 digits. That would not work. If we think about memoization, what can be memoized, what can be remembered, what sub problem can be there? We can get the counts, but we need counts in all sub ranges, right? We can need it from first to last, we can need it from. Okay. So what if we do something like a prefix sum? So what we do is that we store all the counts in an increasing fashion. So at the first place, it's like a cumulative distribution function in some sense. So at the first place, we have the counts till the first place. On second place, we have counts of all the digits from up to the second place. On the kth place, we have count of all the digits up to the kth place, and so on. And the last entry is gonna have the total count of all the digits in the string. And now, if we want to get it for any range, we just need to subtract. So if we want from L to R, then we just need to subtract the Rth element in our prefix sum from the Lth element, and we'll have the count of all the elements in between. So, right, that might just work, and we're gonna have it for just 10 characters, so that should be okay. But, so we have prefix sum. We still might need from any place to any place, and we can get that now in order of one. But so it's gonna be contiguous because it's a substring. So we're looking for ranges, so it can be 1 till the end, 2 till the end, 3 till the end, or 3 till fifth, and so on. If we can fix any start or end place, then we're good to go. We can do it in order of n. But if we have to go over all the start places and all the end places, then it's going to be an n square algorithm, because we're going to be like there, then second, there, then third, there, and so on. Oh, that would be n plus n minus 1 plus n minus 2 plus n minus 3. Yeah, wouldn't work. What else can we do? Just need to think about it. Not sure. And I mean, yeah, at this point, I would have told my interviewer I'm not able to go forward anymore, at least for now. So if there are any hints, please. Otherwise, I can spend some time to think more. So let's do that. We have to include all the digits in between. We can't just drop them. So the counts are important. What if we keep storing the max that we've encountered so far? So uh, if we start from an L index and we go to the R index, then we go to R plus 1. that then what can change? Either some count can become from odd to even, or some count can go from even to odd. If it goes from odd to even, then it might become a palindromic string if it wasn't, but if it goes from even to odd, there's a chance that a palindrome was earlier possible and now it's not, but it might just be possible on the R plus if you move R further by one place. Hmm. What if we move by two places? I mean, we can always have something like 1, 2, 3, 4, 5, 6, 7, 8, and then 8, 7, 6, 4, 3, 2, 1, right? So, or better yet, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So now, and you go from 1 to 2, 3, 4, 5, 6, 7, 8, this max length is just 1. You take from 1 to 8 and then 1 again, still 1. You have to go right till the end for you to figure out that it can be a palindrome because all the digits are odd. But this only happens up to 8 digits, because up to a length of 8, because after 1, 2, 3, 4, 5, 6, 7, 8, and also at 0 and 9 for completeness, something's gonna repeat, right? We don't have that many unique characters, so something definitely would repeat, and some odd would definitely become even, or some even count would definitely become odd. So what can we do? This is interesting that the number of characters is limited to just 10. What if we think in terms of the number of characters? But the problem is deciding the ranges, right? The range can be from anything to anything, and choosing that is n square. How do we bypass that? And the problem doesn't seem subsets. At least the final answer is just going to be binary with a yes or a no, and that can keep changing. It can be a yes, no, or something like that. There's no pattern as such there. So, what can we do? Uh, think more. So all this would also give you an idea of how much time does it take for a person to solve a question. I mean, you can check out my Leetcode page to see how many problems I've solved. If you can ask in the comments below, I can give you a link to my Code Forces webpage. Yeah, so if you want to check that, you want to see what kind of competitive programmer, where do I stand in terms of all the competitive programmers, then you can do that and figure out that how much time does it take for a programmer like that to figure out some questions. And we're gonna evolve together. We also see editorial, so those are very important very important aspect, I feel. You should definitely try out a problem first and then check the editorial, because that's what makes you learn. Doing problems just speeds up the process of doing problems, but the problem which you can't solve when you're trying, you need to check the editorial to be able to make progress in your competitive programming path. Right, back to thinking how to do this. We're bound by the time that we have for the contest, though. Let's see how much time do we have. Ah, we've enough time. We've 30 more minutes. Seems like more than enough. All right. What if we start dividing it in halves? You see if a character is included in it or not. So you pick up the middle element and you see if that's a part of the palindrome. If that's part of the palindrome, then you can go to both ends and figure out the longest string, right? No? No, the left would be any of this side and right would be any of this, any index on this side. So that would be n by 2 into n by 2. That would still be n square, figuring out whether a character is there in a palindrome or not. Alright, let's think of it from this angle. What if we start with the total set? We start with left being leftmost, right being rightmost. And now we can only push inside. If the whole string works, then we've got a solution. If not, we need to keep pushing the bounds so that our even our odd counts come down. If all are even, we've already solved it. If all are even and one is odd, then also we have it. But if we have like five odd counts, then we need to reduce the number of odd counts, and we need to do that by the either moving this left and moving left bound here or moving right bound here. But how do we decide which bound to move? Both might have the same next character, but the character after that might differ. Can we figure out which bound to move? If we can, then we can solve this, but I don't think we can. Okay. Alright, so I'm thinking something like this, that we take the whole set and we remove all the odd counts by checking at which positions can we do that. But when we do that, we'd also have to remove all the elements up till that point from the edge, and that would change the counts again. So that doesn't seem trivial. Alright, let's think of it this way. Let's try to find a sub problem that might help us create a dynamic programming solution for it. Now, if we checked all from 1 to n, we have starting it at 1 and ending it at all the places up to n. Only one thing matters, which is the number of odd counters. For all the counts that we have, the number of odd counts. That's the only thing matters. Oh, and also what matters is what element it is at that place. So I'm thinking, so the largest you would get starting at 1 and ending it at any place. If you start from 2, ending at the same place where you started at 1 could again give you a palindrome, right? But that would definitely not be larger than the current one. So that would definitely not be our solution. So we find the largest palindrome. And then we check for only places to the right of it. Right? Because if we have a palindrome, which is possible from 1 till say kth position, then if we start from 2, we just care about the palindromes if we can make any, which start from k plus 1th position or k plus 2th position. Okay, this can be perhaps like a sliding window, because if we start again from 2 from, so if we move left bound towards right, then this should also go towards right, because all the solutions between this do not matter because they'll be shorter than the one which we already have. So we keep this here, we move the right bound, we move it up till the end, we find the max solution, then we move this one to the right, then we just check here, then we get the max one, and we move it to the right, then we check here. But the problem would be, this might actually work, you know. I am not able to figure out what the complexity would be. It would definitely be less than order of n square, but in the worst case, would it be n square? I'm not sure. But I feel we're on to something here, and if we have to be able to get this in time, which is like 20 minutes left, we should probably start coding. 29 minutes, we have enough time. But we can start coding, we can see where it leads us. Yeah, I think that makes sense. Yeah, I think that makes sense. That makes sense. Okay, so we'll make a prefix sum, which is a list, and we're gonna create this. So we're gonna have a D for dictionary, having all the counts for all the characters. So we initialize it with, we just manually initialize it. Yeah, we can do that. Shouldn't take too long. Let me just copy this string. Yeah. 405060708090. Alright, so for all the characters from 0 up till 9, we have them initialized as 0. And now for character in S, we're gonna do a DFC. We're gonna add this D to prefix sum. We want to make a copy of D because we don't want the dictionary to change. A shallow copy would work just fine. Yeah. So dig.copy. Okay. Yeah. Did it have parentheses? I think it must have because otherwise, yeah. Yeah. Cool. All right. So we're gonna do D of C plus equal to 1, and then we're gonna do a prefix sum dot append D dot copy. So that would give us the prefix sum in my opinion. Let's just check it out real quick. Just for this one, run the code. We have all zeros, then we have a 1 for 3 and all zeros, then we have 1 for 3 and a 1 for 2 and all zeros. Okay, yeah, this seems like the prefix sum, so we are good to go in that sense. Now we'll set the L as 0, and we need to find the max R, and so okay, we'll have the max length as 1 because so max length is gonna be our answer. Let's just return max length as well. It would be 1 in the worst case scenario because our length of S is definitely greater than or equal to 1. Okay, so what do we know now? For L in a range from 0 to the end of the string, and first okay, so what do we need to do? I mean, technically it might be n squared, but because of keeping the upper bound each time, it might just reduce it. I'm not sure if it would work. Let's see. So once we have L fixed, we need to do our iteration, and we're gonna keep a max R, which we're gonna set it as 0. And while L is less than, so this prefix sum has n plus 1 elements. So it can go up to the length of S because that would be 1 less than the length of, okay, just to be neat, or let's just do this, that it should be less than this minus 1. So we definitely have a place to put R, and if max r is less than equal to L at any point, then max r equal to L. Okay. Yeah, because we can't set it as L plus 1, right? Because that might not be a valid palindrome. So, okay, now we need to move R starting from max R till the end, so till the length of prefix sum, and then checking if we'll define this function L comma R, then max R equal to R. And we should also update max length equal to max with max length comma r minus L plus 1, because that's the number of elements that we have. Yeah, I think that's what my logic was. We should also send prefix sum. I just define this is palindrome LR and prefix sum. So we want to subtract the dictionaries. Just sounds wrong. Okay. Okay, we can do this. So the difference equal to empty dictionary for k in L dot keys. What it's going to do is set diff of k equal to r of k minus L of k. Yeah. So we have this difference dictionary now. List of this different dictionaries values. So those are the counts. Now we got a list of them. We're just gonna put it in diff itself because we don't need anything else now. And we need the count if odd ones. So for e in diff, count odd equal to 0. If e mod 2 equal to 1, count odd plus equal to 1. If count odd is less than equal to 1, then return true, else return false. So the else is implicit here. Let's see if it works with the first test case. We got an error. Int object has no attribute keys. Okay, L dot keys. L is just an int object. What did we mean? We meant okay. So L and R we meant is prefix sums L and R. So let's just send those instead. Prefix sum L. Yeah. Alright, this seems to be taking forever. We went to an infinite loop. That means, okay then. We're not incrementing L here. L plus equal to 1. Yeah. Our answer is 6, but the output is 5. Whenever we update this, let's print L and R, run the code. I'll also print this. Yeah. Okay. So 0, 0 is 1, 0, 1 is 2. This string and the palindrome length is 2. That's wrong. What did we do, boy? I think is palindrome function is wrong. Alright, we just also print the diff after we have it as a list. Alright. Oh, so prefix sum, both at the same places, makes no sense. Because that would be choosing no elements. So it must be L plus 1. And here it should be R minus L. So my answer is 5. Let's not print this, and let's see if all these subcases are right. So from 0 to 1, it's a 1 length palindrome, which makes sense because so 0 to 1 would be in the prefix array, and the prefix array would be at the 0th place it's nothing, so 1 minus that would be just 3. 0 to 5 would be 1, 2, 3, 4. 1, 2, 3, 4, 5, and this is a palindrome, so that makes sense. Then from 1 to 5 would be this, which is again a palindrome, that makes sense. From 1 to 6 would be this, that is again a palindrome, good work. From 1 to 5, from 5 to 6 will be something like one element. Yeah, that sounds right. So let's just comment this, try to submit the code, see if it works. Oh, we could have tested it for all the example test cases first. Okay. Seems to be taking forever. Might give it DLE. Yeah, it did. Okay. On the available test cases, 5162, 5162. Okay, so our logic might be right. We can't be sure because we have a DLE. So for all the cases that did execute, it was right, but it of course missed some. All right. we can also go from right to left instead of left to right, if that helps. It might help. So I'm gonna go from I'll just convert this to a list. No, I don't want to do that. I'll just comment this. At this here, we want to start from this -1, go up till max, or skip -1. Let's just use this once. So a range from 1 to 10, list of range from 1 to 10, and list of range of 10 to 1 -1. Okay, so it should be 10 -1 to 1 -1 and -1. Ah, okay, that gave us right. So this -1 -1 -1. Okay. Our sample test cases should work just fine. Okay, not bad. We should wait for a few seconds. 5162 is the answer. Okay. 5162. Submit it and try. So the reason I did that is if there's a too large string and all of it is a palindrome, then it would run that as the first test case and work. Okay, so it failed at some other test case, so clearly our time complexity can be of the problem. I can try to keep optimizing it just a little bit, but without a different logic, we might still just be facing more TLEs. Um, okay. Let's see how much time is left. We have 1 minute and 16 seconds left. Okay. So the video became very long and we've still not gotten a solution. I'm a little sorry about that. I'm not sure if I'm gonna put it up on YouTube or not. Let's see how it goes. Do let me know in the comments below if you watch the video and if you find it useful or not. I'd use the feedback to keep posting or not posting the future videos, right? That would be a great help. So please go down there and comment and let me know what you think about it. Alright, so I'm not able to think of any trivial problem that we've done in this code that would make it not work, and anything which would change the logic cannot be done in a minute. So I'm gonna end this video right here. If I'm able to come up with something, I'm gonna continue the video. Otherwise, that's it for now. We're gonna come back and check the editorials and see how would this be done. Alright, thank you. Bye bye.